On the left of the screen, we've got our primary production site. We call it Site A, and we run most of our production services out of this site. It's basically our active site. Now let's add a second site to the picture, Site B, and we'll operate this as a remote standby site. And by standby, we mean that it hosts replicas of our production services, but we don't use it for production workloads under normal circumstances. And let's say in our example, Site B is just on the other side of town, maybe 50 miles away, so we configured synchronous replication between the two sites. This configuration of two data centers or two sites with data replicating between them gives us disaster recovery capability, meaning that if we lose Site A for whatever reason, we can bring services back up or fail services over to Site B, which, if we look closely at the diagram now, is listed as active. And while Site A is down and unavailable, the business continues to run because Site B is now providing all of the IT services that Site A was prior to it going down. And that's great, but while Site A remains down, we're effectively flying by the seat of our pants in some respects, because if Site B then goes down, and yes, I know this would be rare, but let's say it did go down, then you're in trouble, and potentially in the worst case, facing going out of business. Now then, because we're doing synchronous replication between Site A and Site B, this means that the distances between the two sites aren't large. In fact, we actually said that it was about 50 miles earlier in the slide, meaning that a major local disaster could quite easily affect both sites simultaneously. It could be a tornado, power grid issues, earthquake, you name it. These things do happen, so be prepared. So, an alternative and more robust, but obviously more expensive site redundancy solution could look like the following. This time we've got three sites. Site A is still our main production active site, but this time our apps and services are replicating to two remote sites. Site B over metropolitan distances using sync replication, and Site C over much larger distances using async replication. And because the replication to Site C is asynchronous, it could effectively be thousands of miles away on a different continent, if that works for your business, of course. So with this solution, if we experience a large-scale local disaster affecting Sites A and B, then Site C can become active and keep the business up and running. Though there are several things that we need to note about this. Firstly, as replication to Site C is asynchronous, the copy of our data at Site C that we'll be using to run the business on will probably be slightly behind, meaning that we'll have lost most of our recent updates to our systems. As an example, right, if the local disaster occurs at 3:30 in the morning and replication is configured with a 5-minute lag, this tells us that our data at Site C could be up to 5 minutes out of date, so as it was at 3:25 AM. And any changes since then have been lost. Secondly, because Site C might be on the other side of the country or even the other side of the planet, application response time for users may appear slower due to the increased network latency. For example, if your company headquarters is in New York and Site A and Site B were in the New York area, but Site C is for instance in London, then users at your headquarters in New York will almost certainly be kicking up a fuss about application performance. But while they've got a point, the performance drop will still probably be a better option than no access at all to the data. So, that highlights the concepts of site redundancy. Now then, replication can be array-based or host and application-based. Let's have a look at array-based first.